Hi, class. Today we're going to go over lesson 6.8, and we're going to talk about angles, lines, and transversals. So let's get started on that. This is a little bit of a change up from what we have been doing in chapter 6. So far in chapter 6, we've talked about transformations, and we've had four of them. We have had translations or slides, reflections, also known as flips. We've had rotations, sometimes called turns. And lastly, we have had dilations, which make your figure bigger or smaller. And sometimes those are called enlargements or reductions. So let's get going on with our new definitions from this chapter. The first one we have is a transversal. So a transversal is a line that intersects two or more lines at different points. So right here we could see an example of a transversal. We have two parallel lines, meaning these two lines do not intersect. And then we have a third line, which is called a transversal, that intersects both of these lines. So this is how we're changing up chapter 6. Instead of talking about transformations, we're now going to be talking about all the angles that are made when we intersect these two lines with a transversal. So again, a transversal is a line that intersects two or more lines at different points. Start with the second definition here. So corresponding angles. So when there's a transversal line, it creates corresponding angles. And it turns out that these corresponding angles are congruent to each other. So basically what a corresponding angle is if we have these two parallel lines here, one here and one here, and we have a transversal that intersects them, we'll make the transversal red so we can see it's a little different. Then the angles that are in corresponding spots, for example, if I look at this angle right here, we'll call it angle A. And the angle that is the exact same spot on the other line there, we'll call it angle B. Notice how these are both on above the line, right? Above their individual line, and they're to the left of the transversal. We would call these corresponding angles, and it turns out that these angles will be equal to each other or congruent to one another. That means if angle A is equal to 20 degrees, then angle B will also be equal to 20 degrees. Or if angle A was equal to 30 degrees, angle B would also equal 30 degrees. There are some other examples of these corresponding angles. For example, we could have these right here. We'll call it angle C and angle D. These would be corresponding. They are equal to one another. We could also have these angles right here. We'll call that angles E and angle F. Angles E and angles F are equal to each other. And then we have the last set right here, these two ones that are beneath the parallel lines and to the right of the transversal. We'll call it EFG and H. Angles G and H would be equal to each other as well. So what we're going to do is we are going to be basically plugging in numbers into these different transversal angles, and we would have to find out what is our corresponding angle and what is equal to it. So that's what we're going to be doing a lot in this section. Got another definition for you though. Our alternate interior angles. So since a transversal cuts a line in two, we know that these angles will add up to 180 degrees. Knowing this, we could say that corresponding angles are congruent. This should say that alternate interior angles are congruent. Alternate interior angles are congruent. So what do I mean by interior? Well, by interior, what I'm basically saying is on the inside of these two lines right here. The inside of these two lines. So right now, we do not want to consider anything outside of these lines right here. We are only looking at the interior of our two lines. So that's what interior means here. It means inside of our two parallel lines. Now, the alternate part means they are on opposite sides of the transversal. So here we see angles 1 and angle 2. Angles 1 is on the left side of the transversal, and angles 2 is on the right side of the transversal. So that means angle 1 is congruent to angle 2. Similarly, we have these other angles here that are one we have on the left side here. We'll call it angle 3. We'll call this one over here angle 4. Notice how they are both inside our two parallel lines and on alternate sides of the transversal. That means they're alternate interior angles, and angle 3 is congruent to angle 4. All right, so I just wanted to rehash everything we just talked about there. So far we have learned about corresponding angles, and two angles are corresponding when they have corresponding positions, so either both above the line and both to the right of the transversal, or both below the line and to the left of the transversal. We would call those corresponding angles. We have alternate interior angles when they are on the interior of our two lines and on alternate sides of the transversal. And it turns out that if parallel lines are cut by the transversal, the corresponding angles are going to be congruent. Also, alternate interior angles are congruent. We also have alternate exterior angles. Alternate exterior angles are the exact same thing as alternate interior angles, except they are on the exterior of your shape, of your parallel lines. So, for example, we would block out this place in the middle. This is the interior. We wouldn't want to look at it. We would want to look at the exterior, and then we would just have to find angles that are on opposite sides of the transversal, like angles 1 and angle 7 there. Or right here, we can look at angles 8 and angles 2. All right. Other than that, we can go ahead and get started on some questions here. So, these are an example of what type of angles, and they are what? Are they alternate interior angles and they are congruent? Are they corresponding angles and they are congruent? Are they alternate interior angles and they are different? Or are they corresponding angles and they are different? Go ahead and think about this one for a second. Feel free to pause the video and then try your best to get the answer. So if we were saying that those were corresponding angles and that they were congruent, then you would be correct. These are corresponding angles and they are congruent. They are corresponding angles because they are both in the same spot. They're both above the parallel lines and to the right of the transversal, and they are congruent because all corresponding angles are congruent when our lines are parallel. All right, let's get on to our next slide here. Okay, so angle 1 is congruent to what angle? As a hint, I want you to find its corresponding angle. So angle 1 is congruent to what angle? Is it angle 2, angle 6, angle 7, or angle 5? Right here is angle 1. All right, feel free to pause the video if you need to, and then try your best to get your answer. Okay, so if you chose that angle 1 is congruent to angle 5, you'd be absolutely correct. If we look at our two parallel lines here and our transversal cutting them in half, the one that is in the same spot as angle 1 would be angle 5. It's both to the left and above the parallel line, which means that is its corresponding angle, and corresponding angles are congruent. All right, here's another question for y'all. What is the measure of angle 1? What is the measure of angle 1? Here's angle 1 right here. You have to find the measure. Feel free to pause the video if you need to do this. But is the angle 150 degrees, 1 degree, 30 degrees, or 180 degrees? All right, if you said that was 30 degrees, you're absolutely correct. The angle 1 and the one that has 30 degrees here are corresponding. They're the same angle, which means they're going to have the same measurement. So angle 1 would be the same as this, which is 30 degrees. All righty, last question for us, and then you guys will have to write a conclusion. What is the measure of angle 2? So here's angle 2 right here, and I want you guys to find the measure of it. Is it 30 degrees, 180 degrees, 150 degrees, or is there not enough information to solve this problem? Feel free to pause the video if you need to and get your answer. Alrighty, so if you use 150 degrees, you're absolutely, and here's why. Notice here how this angle 30 degrees and this angle 5 create a 180 degree angle. Since it's just a straight line, we know all straight lines add up to 180 degrees. So to find what the measurement of angle 5 is, we would have to do 180 degrees minus the 30 degrees that are right here, which means angle 5 is equal to 150 degrees. And then since angle 5 is a corresponding angle with angle 2, we know that they are the same. So angle 2 is also 150 degrees. Alrighty, everybody, so that's all I had for you on notes today. What I would like you to do now is write a 2-sentence conclusion about what you learned today. Remember, you could talk about things like our corresponding angles. You could talk about alternate interior or exterior angles. And absolutely, you should talk about transversals. That should mention there and why in your conclusion at some point. What is a transversal? What do we know about it? And kind of what type of lines does it cut in half? Alrighty, everybody, I will see you all in class tomorrow. Have a great rest of your day. Peace out, everyone.